We will continue with the hyperbolic functions again, and today I want to give you some derivations and the integrals of the hyperbolic functions, okay? And let me continue. Okay, let u equals to u of x, okay, and what can we say about the derivation of the sine hu, okay, and it will be cosine hu, okay, and the del u over del x, okay, and the del over del x cos hu, it equals to sine hu del u over del x, and the del over del x tan hu, it equals to secant square hu del u over del x, and the cot hu, it's equal to minus cosecant square hu del u over del x, and the derivative of the secant hu, okay, and it's equal to minus secant hu times tangent hu del u over del x, and the derivation of cosecant hu, it's equal to minus cosecant hu times, okay, cot hu del u over del x. Okay, and what about integrals? Integral sine hu, it equals to cosine hu plus c, and the integral cos hu, it equals to sine hu plus c, okay, and the integral secant square hu, it equals to tan hu plus c, and the integral cosecant square hu, it equals to cot hu plus c, and the integral secant hu tan hu, of course there must be del u, okay, it equals to minus secant hu plus c, and the integral cosecant hu times cotangent hu del u, it equals to minus cosecant hu plus integration constant, and the let's continue with some examples, okay. integral cot h, okay, 5x del x, it equals to integral, we know that cos h, okay, 5x over sine h 5x del x, and if you choose u by the sine h 5x, okay, and the del u will be, okay, 5 times cosine h 5x del x, okay, and after that you can write this integration part by the 1 over 5 del u over, okay, u, so that is the integral, okay, and the I equals to, okay, 1 over 5 integral del u over u, and it's equal to 1 over 5 ln absolute u plus c, and you can write the 1 over 5 times ln absolute, okay, sine h 5x, okay, plus c, right? And another example, integral sine h square x del x, okay, and its integral, it can be cosine, okay, h 2x minus 1 over 2. Remember the identity, okay, and it's equal to integral, okay, 1 over, I'm sorry, maybe it can be written outer of the integral, okay, and the 1 over 2 times integral cos h 2x minus 1 del x, okay, and the integration equals to, okay, 1 over 2 times 1 over 2, okay, sine h 2x, okay, minus x plus c, and it's equal to 1 over 4 times sine h 2x minus x over 2, okay, plus integration constant. Okay, and the let's talk about the cosine hx graph and the sine hx graph, okay, and so what can we say about the inverse hyperbolic functions, okay, and Firstly, let's talk about the y equals to cosine hx, okay, and its domain, okay, is the whole real x-plane, but it's not one-to-one function. I mean that if you sketch the cosine h function, okay, on the coordinate plane, you will obtain this curve, okay. This point is 1, okay, this is the y equals to cosine hx, okay. As you see, when you sketch this some horizontal lines, okay, and you will see this function is not one-to-one, okay, because of these points, intersection points, okay. Every line has two intersection point on the curve, okay, so we can say it's not one-to-one function, so non-invertible, okay. Of course, you can restrict this domain, okay, and you can evaluate the inverse cosine hx function. For example, when you restrict this function by the positive side of the x, okay, and subtract this domain from the whole real line, okay, you will obtain only right hand side of the y axis, okay, and the restricted domain y equals to cosine hx, okay, and therefore that means x is larger than or equal to 0. So, and okay, r will be, okay, and the y is larger than or equal to 1, okay. So what can we say about this, okay, and it will be easy to understand now because it's invertible, and the y equals to, okay, inverse cosecant hx, and its domain will be larger than 1, and its range, okay, will be greater than or equal to 0, okay. And let me sketch the inverse cosine hx function, okay. And firstly, okay, to sketch the y equals to x line, okay, it will be easy to understand the invertible functions when you're sketching, okay. And this will be like that function, okay. This part is 1 and this part is 1, okay, and this function is y equals to inverse cos h x function, okay. And what can we say about another hyperbolic functions, which is sin h, okay, and we know that y equals to sin hx function, okay, and it's for all real x, and we know that sin h function is increasing function, and therefore we can say on the whole x line, okay, it is 1-to-1, okay, and it is invertible, of course. And what can we say about it? can say y equals to sine inverse sine hx if and only if, okay, x is equal to sine hy, okay, and let me sketch it on the coordinate system, okay. And this is again y equals to x, okay. This is the inverse sine hx, okay, and its domain minus infinity to plus infinity, and the range of it same, minus infinity to plus infinity, okay, and don't forget it, this part is sine hx, okay, and the other one is oops, I'm sorry, I want to sketch this part again, okay, and some mistake here, okay. Okay, look at me, and firstly I want to sketch sine hx, okay, and after that I will sketch the another part, which is the inverse, okay. This is y equals to sine hx, okay, and the other one is this is the y equals to sine inverse sine hx, okay. And you can find the, of course, and you can evaluate the inverse tan hx, okay, and because of it is increasing function and the invertible function, okay. But for the inverse cot hx, okay, you must restrict this function again, okay, and you can find lots of informations from your book, okay. And now I want to continue with another subtopic, okay, and which is I'm sorry, maybe we can continue with this inverse functions derivation, okay, and maybe totally this will be important for you, okay, and the derivation of the inverse hyperbolic functions. Okay, and firstly del over del x of inverse sine hx or inverse sine hu, okay, and it's equal to 1 over square root of, okay, 1 plus u square, okay, del u over del x, and the del over del x inverse cosine hu, okay, is equal to 1 over square root of u square minus 1 del u over del x, okay, and it is for u is larger than 1, okay, del over del x inverse tan hu is equal to 1 over 1 minus u square del u over del x, okay, and for absolute u's larger than 1, I'm sorry, this part is less than 1. Okay, and the del over del x inverse cot hu 1 over 1 minus u square del u over del x for absolute value u is larger than 1. Del over del x inverse secant hx secant h u, okay, and it's equal to minus 1 over, okay, u times square root of 1 minus u square del u over del x, okay, and the for 0 is less than u is less than 1, and the del over del x inverse cosecant hu equals to minus 1 over, okay, again, and the absolute value of u times square root of 1 plus u square del u over del x. It's for u is not equal to 0, okay. And let's calculate the inverse cosecant hu, okay, and the derivation of this function, okay. If y equals to inverse cos hu, okay, so what's the y prime, okay, and firstly let's choose u by the cos h y, it's true, okay, and after that del u over del x equals to, okay, and the del over del x cos h y, and it's equal to sin h y times del y over del x, right? And we know that the del y over del x equals to, okay, 1 over sin hy times del u over del x, okay, and it's equal to 1 over, okay, square root of cos h square y minus 1 times del u over del x, right? And after that it's equal to 1 over square root of, okay, and the cos hy is u, we know that, so it's equal to u square minus 1 times del u over del x. We have just found the y prime, okay, which is the inverse cos h u prime. It's equal to that, okay. Okay, and similarly you can continue with the some integration, okay, and integral del u over 1 plus u square, I'm sorry, integral del u over square root of 1 plus u square, okay, is equal to inverse sin h u plus c, integral del u over square root of u square minus 1 is equal to inverse cosine h u plus c, integral del u over 1 minus u square, okay, it's equal to inverse tan hu plus c if absolute value of u is less than 1. Okay, it's equal to inverse cot hu plus c if absolute u is larger than 1. Okay, and the integral del u over u times square root of 1 minus u square, okay, it's equal to minus inverse secant h absolute u plus c, okay, and the, or you can write it by the minus cos inverse cos h, okay, cos h 1 over absolute value of u plus c, okay, and the integral del u over u times square root of 1 plus u square, okay, is equal to minus inverse cosecant h u, okay, and it's the absolute value of u plus c, or another point, minus inverse sin h plus c, okay. Example, two del x over square root of 1 plus 4x square, okay, and if you choose the u by 2x, okay, and the del u will be 2 del x, okay, and after that you can write this integral by the terms of u and del u's, okay, del u over square root of 1 plus, okay, and the u square, we know that, and we know this integration is equal to minus inverse sin h, okay, 1 over absolute value of u plus c, okay, and the not, this is only u, I think. Let me look at the first equation. Yes, u. So sin h u plus c, and it's equal to minus inverse sin h, okay, u was 2x, so that's the total result, okay, and let me write this some identities. Okay, and the inverse sec hx equals to inverse cos h 1 over x. Okay, and the inverse cos h x is equal to inverse sin h 1 over x. Okay, and the inverse cot h x is equal to inverse tan h 1 over x. And the logarithm formulas for evaluating inverse. Hyperbolic functions. Okay. First one, okay, and the inverse sin h x is equal to ln of x plus square root of x squared plus 1. Okay, and for x is real line, on the real line, and the second one inverse cos hx equals to ln of x plus square root of x square minus 1, and therefore x is larger than or equal to 1. And the third inverse tan hx, it's equal to 1 over 2 times ln of 1 plus x over 1 minus x, and the for absolute value of x is less than 1. And the fourth one inverse sec hx is equal to ln of 1 plus square root of 1 minus x square over x, for the 0 is less than x, x is less than or equal to 1. And fifth one inverse cos hx, it equals to ln of, okay, 1 over x plus square root of 1 plus x over absolute x, okay, and therefore x is not equal to 0. And the sixth one inverse cot hx, it equals to 1 over 2 times ln of x plus 1 over, okay, and x minus 1, and it's the for absolute value of x is larger than 1.